So welcome back. Today I will talk about Apache Hive. So Apache Hive is used when data becomes very big. So in this topic we start from basic ideas and slowly understand how Hive help us work with big data using SQL. So let us understand the problem before learning Hive. So when data is small, we can easily store and analyze it using Excel or normal database. But when data becomes very large, these tools stop working uh, properly. To process very large data using Hadoop, we must write very long Java programs that we already seen. So these programs are difficult to write and difficult to understand also. So now instead of writing such programs, Apache Hive allows us to write simple SQL. Okay. For example, if we want to know how many users belong to each country, we can write a simple SQL query that says count users country wise. Okay. Then we can filter out the country. Apache Hive takes this simple SQL internally and converts it into big Java program. Internally it converts. So we write SQL very easily, right? So and Hive does that hard work in the background. Now let us understand when Apache Hive should be used. So Hive is used when data is already stored and is very large in size. Hive is mainly used for analysis of old data, which means historical data. So this means Hive is good for questions like how many users are there, how much sales happened last year, or which country has more customers. So Hive is not used for live systems where we need instant results. So Hive is for analysis, not for real time work. So now let us understand where the data is kept. So Apache Hive does not store data inside it. Okay. So the actual data is stored as files in large storage system that is nothing but HDFS. So Hive only keeps the information about the data, which means metadata. It stores only metadata such as column names, data types and file location. So Hive help us read big data files properly, but does not store data itself, right? Before using Hive, we must tell Hive how the data looks. For this, we create a database called table. So a database is just a container. A table contains column names like ID, name, country, and age. If you see here in this particular slide. So by creating the table, we are telling Hive what type of data exists in each column, and this help Hive understand the data structure, right? After creating the table, we connect the data to it. So the data can be stored in big storage system or on our local computer. We tell Hive where the data files is located. So Hive does not change the data. It does not create a copy. It only remembers the file location. Okay, whether it is in HDFS or whether it is in your local computer, it only points towards the file location. After this step, Hive is ready to read the data. Now we start working with the data. So we can read all records from the table. We can filter data using conditions. We can we can sort data and count the records. So all this done using simple SQL queries. So if we already know SQL, using Hive becomes very easy. So after reading data, we analyze it. So we can group data into group data to find totals. How many students are there, or how much sales happened. For example, we can find how many users are there in each country. We can also combine two tables such as users and orders to understand user activity better. So this help us useful to get useful information from large data. So when data becomes very large, reading everything again and again is slow. To reduce this problem, data is divided into folders that we call it as partitions. For example, data can be separated country wise. Just think of when we search one country, only the folder is read. Okay. only the folder, that particular folder. For example, if I search India, that particular folder is red. Okay. This saves time and improves the speed. That is what we do in partitioning. Now, sometimes dividing data into folders is not enough. So data is further divided into fixed parts. This method helps Hive work faster. When very large tables are joined together, this will be the best thing. That is nothing but bucketing. Now, Hive also supports advanced analysis. For example, if we rank users based on age inside each country, okay, this helps us to compare users easily. By using hash function, we'll be having this all these window functions, okay, without writing complex logic. So after analysis, we may want to save the result. So Hive allows us to store query results into tables, okay, or we can insert data into an existing table. The two things are there. We can store it in new file, or we can store it into existing file, okay. Now Hive also supports updating and deleting data, but this requires special settings, okay. So these operations are not used often, but because Hive is mainly used for analysis, okay. If you see here, to make Hive work efficiently, some good practices are followed. Using better file formats improves the speed. Dividing data properly reduces the processing time. Avoid reading unnecessary data. This improves the efficiency of Hive. So finally, let us understand the main idea. Without Hive, big data processing requires long programs. With Hive, we only write SQL. Hive takes care of everything internally. That is why Apache Hive is simple and powerful. Thank you guys. If you are having any doubt, let me know in the comment section.